This is what happens when you run Linux. All good?
Yeah.
Great. So thank you. So this is Jöran from SIPGate. SIPGate, I think, might have sponsored every single CommCon that we've done.
In person.
In person. You didn't do the virtual ones.
We didn't.
It wasn't CommCon.
We didn't the first one.
Oh, did you not?
No, we didn't.
Well, you were there in spirit,
yeah.
and that's the main thing. So no, they've been big supporters of CommCon since the very beginning, whether or not they were sponsoring or just attending. They always send a good number of people, so I thank them very, very much. Yeah, Jöran, I've known you for a long time, tinkering on the Asterisk project. We even got to work together over a little bit of time, which was fun. And you're going to talk to us about joining new and old, and so I'm going to let you get on and do that.
Yeah, thank you. Yeah, thanks for joining. My name is Jöran Vinzens. I'm a web developer at SIPGate. I'm employed there now for 13 years, which is amazingly long. And I'm in the VoIP business since I'm in a professional business, over 20 years. And in this time I came along a little bit with, in SIPGate, all the history we have about telecommunication and stuff. We were facing the new world of telecommunication and WebRTC and mobile stuff and everything. And we did it our own way, I think. And this is a little bit of storytelling, how we did it. So first of all, where are we coming from? In 2004, we started our business, which is amazingly 20 years now for telco. In 2004, we were a little startup connecting Asterisk with HFA-Karten from Sangoma to E1 interconnects from Deutsche Telekom, which is a nightmare, I can tell you. And the setup looked a little bit like that. I think it was Asterisk 1.1 or 1.2, something like that back in the days, which have HFA cards with physical lines in there. And we used OpenSARE for a proxy and RTP engine for relaying all the traffic. And the OpenSARE for SPC's functionality as well. And back in the days, there was no WebRTC. There was all the telco stuff, but no WebRTC at all. There was not even fast internet speeds, so you can rely on having real-time communication over the internet at all. It was all UDP, plain or UDP, no encryption, no nothing. But it was fun. We used the Asterisk for carrier connection to handle all the phone number stuff and resolve phone number to customers and stuff. We used it for accounting, so we earned some money from them. Of course, back in the days, we already had the problem of lawful interception. We did that within Asterisk as well. And in 2008, I think, we thought, okay, it might be a good idea to implement some more PBX functionality to get some more business customers and do stuff like voicemail and hold and transfer and stuff. And so we introduced a new component. It's also an Asterisk. We put there all the business logic we have. We connected our own service via AMI to that in order to orchestrate all the different asterisks and bridge between the asterisks. It's all handwritten, it's Perl, wow. And it's great fun, not. From there on we proceed. In 2013 we became MVNO, Mobile Virtual Network Operator. A colleague of mine did a talk on CommCon in 2019. So if you follow the link, you have her talk, which is amazing, I can tell you. It's a fun story, so just proceed. And back in the days, or still now, we have mostly traditional PBX customers. So there was no fancy new stuff our customers demand to have. But as always, they hear about new technologies and we have to proceed anyhow. And this is why we thought, okay, we need to change anything and we can stuck with what we have. And so we thought about we need to start over again. But why we have to start over? It's not just, okay, let's start over again. There are two main reasons. First of all is incompatibility. The Asterisk became incompatible to new standards or in AMI, we couldn't proceed anymore because they changed it so much that we got stuck with Asterisk 11. And as well, the technical evolution in telecommunication, like WebRTC, like AI integration and stuff, we need to use modern technology to get on there. First of all, AMI, there was a breaking change from Asterisk 11 to Asterisk 12. I think some of you already know the pain of this update. And in terms of technical evolution, this is not the phone we are using every day anymore. So we use something more modern, most likely any websites with just a headset. And we thought, okay, we have to conclude what's the new technology we need to implement. And first of all, there's HD communication, WebRTC technologies and applications, mobile apps you use on the phone while going or while on the ride, don't know. AI integration to boost your productivity. And within Zipgate, it's very important that people who doesn't know telco are able to work on telco. Therefore, it's the new platform we are building up must be easy to work on. As well, in future, maybe, we don't know, video comes on plan for telecommunication. It's not that important to have video at all because no one wants to talk to a stranger on video. That's pretty easy, so we just ignore it right now. So what were the challenges, or what are the challenges? In 2018, we got great support from Dan what are the components we want to use, what is the technology we want to use. Therefore, we came up with ARI. But all the other stuff were pretty much unclear, and we had to figure it out. Then we got to a halt on that project after we had the first small MVP, so we had a prototype, and then we needed to do some other stuff. And in 2020, we started again with a prototype, and I think you can remember 2020, in the beginning, there was something else which came in place and which disturbed us a little bit in our workflow. But at the end, in 2021, we got our first MVP for the new platform, for the new technology we use. And it was conferencing service. So you call a number, you get in a conference room, you can talk to other people, and you can hang up. That's basically it. For the setup-wise, it looks like this. We have the Asterisk instance, which is running on bare metal. We use ARI to connect our own ARI controller, which is written with the team I'm working in. And then we have an abstraction to a PBX, which implements all the business logic of a PBX you have to know. So which customer has what number, if you press any digit, what should be happening, all the billing stuff, accounting stuff, and so on, is done on top of there. So all the people who are implementing the business stuff doesn't have to know about SIP, RTP, quality of service, and so on, and also not about lawful interception, because this is something we want to do down in the platform. Most far away from all the people who are with the thoughts, how can I present it to the customer the best way, or what are the features the customer want to have. From there on, we use Kama-Elio, not OpenSea anymore because time. And we use RTP engine because it's just better than RTP proxy. And also we still have the Kama-Elio SBC, which is doing still SBC stuff. With the SBC, we can use TLS, SRTP stuff as we want, and UDP stuff as well. It's just all handled by the instance you register to. There we decide whether we want to have TLS or UDP. So in order to have a secure communication, you better use TLS. In 2024, right now, we are nearly feature complete. So we can stand here and tell about what we have done and what were the challenges. And I picked a couple of pain points. ARI, if you work with ARI, I don't know, who of you worked with ARI on Asterisk? Yeah, okay. I can tell you, it seems unfinished. If you work with that, every time you come across some odd situation, you think, okay, it's not finished. But if you have done it, okay, you don't know how to do it a better way. Then the documentation, I would call it difficult. because you have to understand what's behind that in order to have it done. So it's a kind of bad situation. And always I work on the documentation. I think, okay, after that, I will do a PR to make it better, but at the end, I don't know how. So, bad. Then we came across, there are no standards for AI voice. Every AI supporter wants voice in another way, so you have to adapt anything if you want to have AWS or Amazon or Microsoft or Google, whatever. You have to adapt the audio for their standards. Then there's no clean signaling standard for WebRTC, so you have to do all the signaling part yourself, and the only thing which is clear is the RTP stuff or the SDP stuff. And how you get there, it's depending on you. So we have to find something in there. And the most painful thing, I would say, it's the integration of old zip phones or the old telco stuff, because this is legacy, heritage, I don't know how to call it, but this is a huge regulated ball of mud we have to handle. And some examples of that is history info or diversion handling, which is really a nightmare, especially in Germany where everything is regulated. The P headers, P asserted, P preferred, whatever you want to have. Emergency call handling like E911, there's a similar thing in Germany or in the EU at all. How to handle anonymous calls, if you have a blockade or not, or what to do with that. The refer handling within the Asterisk is interesting. And then stuff like subscription, message waiting indication, DTMF, and so on and so on. It's all you have to implement just to satisfy your old customer. You cannot just ignore it. You have to do it. And then one big pain point or one challenge was the requirements within Zipgate. So we have different stakeholders, and they have a focus on different things. Might be it a new feature, new cool feature, or might it the migration of the old platform to the new platform, or whatever. We have to do it all together. Maya, sitting there, has done a talk last year on CommCon, addressing exactly that, how we did that, and how we split up the interest and what we did. But enough talk about history. How does it look like? So the basic setup, I already showed you this picture. We have something like that. We have the Asterisk handling all the zip stuff. There attached is the ARI controller through ARI, of course. And then we publish everything to a PBX, which is written by our own. And there all the databases are connected, what customer has what number and so on. And from there on we have the Kamalia proxy holding the AOR of the customer, and the RTP engine trigger is there, as well as we have the SBC. If a customer registers, it goes to this SBC to the Kamailio, and then the phone is reachable. For AI integration, we did something like that. We made our own cloud adapter, where we push external media RTP stream, it's a TCP stream, to that cloud adapter. Then we translate it to anything we need. For example, if we have Google AI, we convert it this way. If we have, for example, AWS Kinesis, we make it in another way. And if we have the need of doing more stuff, we use, for example, AWS Kinesis to spread out this, I think it's called fan out, to publish it to multiple endpoints. We also have OpenAI Whisper within our data center, so we have this transcription part within our own data center. We don't have to push data to a cloud service, which is an unanswered question in Germany about regulation, about how RTP of a call is allowed to be published anywhere. But yeah, so with OpenAI Whisper, you can just let it in your own data center. Within the Asterisk, we did something like that. We have on both ends of the Asterisk, we have PGI zip channels. Both PGI zip channels are put in a bridge, and both two bridges are connected via local channel. And if we decide we want to have an, I don't know, AWS stuff ongoing for that call, we initiate an external media stream, put that one into a third bridge, and then connect any of the other bridges to that new bridge. So we have the mixed audio going out to the external media. if we want to have a separation of the two speaking peoples or the multiple speaking people, Asterisk has something in place as well. It's called Snoop Channel. With Snoop Channel, you can spy on a certain direction of the internal channel or an external channel. We do it only on local channel, which is easier for us. And then you have only the upstream or the downstream put in one bridge, and so you have a distinct direction within the outgoing channel. So you can, for example, do something like chat-like view during the call while it's running, which is quite nice to have a transcription while on the phone, so you can read what the other said, maybe you haven't understood or whatever. For the WebRTC stuff, we have something in place already, and we have to migrate it to the PBX we now call we call it for Zipgate. And therefore, we have this WebRTC client, which is connected to our TLS zip WebSocket translator, which is registered to Zipgate like any other phone we have out on the market or in the network. So for the internal part, we don't make any difference if it's a phone, legacy phone, UDP phone, whatever, or WebRTC client. We don't see the difference there. The WebRTC client on its own, it's connected via WebSocket to this new machine, and it's communicating with the PBX part using message queue just to exchange further data like call history, additional information, something like that. So we have a more pretty and more complete use of full window, and we don't have the limitation of a phone with just a dial pad and a little display. So we can add more information, more productive solutions for our customers. For the mobile client, here we have the limitations of Google and Apple, of course. So we need to wake up the client anyhow. What we do is, if we know the client is a mobile client, we trigger the push service of Apple or Google just to wake up the client. The client registers to the Camalio proxy. We get the location in the proxy. The proxy publish this address of record or the fact that the client is registered now to Kafka, which is consumed by the PBX, and then we know, okay, the client is woken up. We can establish a call to the client, and then we send out an invite like any other client. So it's pretty easy there. For the backend, we have Camalio using anycast IP addresses, which is a little bit tricky for IPv6 and TCP, but it's working fine. From there on, we use the dispatcher to address the stateful Camalio instances using the USC module in the Camalio and the dispatcher to dispatch further to the Asterisk instances. If you want to drain some Asterisk because of maintenance, whatever, we just tell the dispatcher, don't give us any traffic anymore, so it drains, and until the last client hangs up, we can restart the service without any interference of any ongoing call. For the Asterisk to the PBX part, it looks a little bit like that. We have this Asterisk. We have an open source project called ARI Proxy, which connects from the ARI interface to Kafka. There are some others out there with the same name connecting to RabbitMQ or NUTS, I guess. From there on, we have our ARI controller consuming out of the Kafka and sending commands to the Asterisk using Kafka as well. And from there on, we have the adaptation from the ARI part to our internal API. We call it ITI, Internal Telephony Interface. It sounds funny. From there on to the PBX, which is doing all the magic stuff. I did a talk on that for building up high distributed ARI status application. You can follow the link. I think it was on Astricon. I'm not pretty sure, but you can follow the link for the entire story. In summary, it was a lucky guess that open source back in the days would be the solution for us, that we have something future-proof with Asterisk and OpenSea, which turns out to be Camalio or OpenZips now. And I think we got lucky with the decision. And the most interesting part was all the stakeholders get together under one roof and find a solution for that. I think I'm at the end. If you want more information, I publish the slides later on. You can follow then. I think we have maybe one question. I don't know.